All right. Welcome to Module 2. So we are now jumping ahead, forging ahead in this class. And last time in the first module, we were talking quite a bit about the context of climate change. What is climate change? How does it differ from global warming? What is happening to our planet right now? Really just sort of the big 30,000 foot overview. But that being said, how do we actually know that the warming that we've been experiencing is something that we should be alarmed about? Well, really the only way that we can figure that out is we have to compare recent events, recent warming, to prior events, to prior climate changes, because then that gives us an idea of, is this just business as usual? Or is there something really alarming happening here? And so that's really the big overarching purpose of this second module, is to sort of delve into that idea of how did our past Earth look like? So that's what we're talking about today. We're talking about the past climate of the Earth. And I'm going to take this in two main parts. First, I'm going to talk about how we know that we can look into the past. What are some of the reliable ways that we can look into the past? And then after a few videos of going through that, I'm then going to jump into the reconstructed climate. The best guess, using all of the information, all the data, all the evidence we have, basically scientists piecing together Earth's past climate. So let's jump in. All right, so part one, we are going to start to figure out how can we even look into the past. And there are a few different things that we need to be able to do. So I'm going to do a few videos right now that are going to walk through some of what we do to look into the past. So here we go, just a review from last week. So if you remember from last week, I said that Earth's global average temperature has risen quite a bit since 1880. We have risen on the conservative side 0.65 degrees Celsius, and on the much more drastic side 1.05 degrees Celsius. Now, that doesn't sound like a big deal. Obviously, weather conditions can change a degree from 1 hour to the next, and it doesn't really seem like that big of a deal. But this is all conditions changing like that. It's not just like a single 1 hour change. This is a change in the entire average of Earth's climate. So when talking about this from a large scale climatic perspective, this is actually really, really substantial. Really substantial, and it's really, really fast. And the results that we've gotten here have been based on data collected from tens of thousands of resources all around the world, tens of thousands of sources all around the world, analyzed and scrutinized and categorized by major climate agencies with very little disagreement. And so this is ultimately that grand result. Ever since 1880, we have had accurate temperature records, and we have had good protocols in place. We've had rules that we use. And so we've had a really good picture of what's going on. Now, with that being said, though, this is all well and good to 1880. But what about before 1880? How do we actually know about prior climate shifts prior to 1880, since we didn't have kept accurate records prior to 1880? How do we know that there has been at least some variation over time, and what that variation actually was? Well, in order for us to figure that out, I need to introduce the concept of a proxy. So a proxy is a representative of something. It's basically something that speaks for something else. Let me give an example. I am a big beer club person. One of my favorite beer clubs is called Modern Times. And There are some times where, in order for me to pick up the stuff that I've ordered, I don't necessarily have the opportunity, the time, or anything to actually go pick it up. So what I can actually do is ask somebody else, hey, can you go pick this up for me? And then I designate that person, hey, they're going to come pick this up for me. They go, they pick it up, and then they bring it to me, and I give them like a little thank you gift or something like that. Well, that person who is representing me is my proxy. Another good example, not so much for an asynchronous class, but if I ever got sick and had to miss a class for a day, and but there was really, I was in a time crunch, there's no way that I could cancel a class, and I needed somebody to cover for me, that person who would be my substitute is a proxy for me. They have been designated to speak for me. Well, since we don't have accurate temperature records prior to 1880, we use proxies to represent temperatures prior to 1880. In order to make sure that these proxies are accurately speaking for us, we calibrate them using current observations. So we look at what the proxy said about 1950 compared what the actual temperature record said about 1950. And we do that for every year. And the more data we have and the more that we do this, the more dialed in we have these proxies and a better sense of what they're telling us. And there are numerous proxies that we use. There are three that I just mentioned here, but there are even more than just these three, but these are the big three ones. Ice cores, tree rings, and sediment samples. And each one tells us a different story. And what we can do is, combined with that and geological and archaeological evidence, we can piece all of those things together to put together a pretty good picture of past climate, what we would call a reconstruction. So that is how we look back into the past. We use these paleoclimate proxies. Now, what I'm going to be doing in the next few videos is I'm going to be showing you how we actually use these proxies. But what I thought I would do right now is just briefly show you a little bit about each of these proxies. So the first big proxy that we use are what are called ice cores. So in some parts of the world, ice is pretty much permanent, meaning that every single year, a little bit of snow falls, but the temperature at that region never jumps above freezing. As a result, because it never jumps above freezing, that snow that falls stays there. Well, trapped inside that snow are little bubbles of atmospheric air. And so every single year, a little record of the past is actually stored in that layer of snow. And then the next year, new snow falls on top of that. That's a new layer. That's a new record. Then the next year, more snow on top of that. That's a new year. That's a new record. And so on and so forth. And as long as there's no melting happening, we can actually go to a location, drill this really long tube called a core, pull it out, and then looking at that tube, we can actually look at each of the layers, extract the gases that are inside that layer, and analyze them to tell us about the past. One of the big places that we do this at, one of the main places that we do this at, is the Vostok Research Base in Antarctica. And this is a really interior base in Antarctica. It's really cold there. It's been cold there for hundreds of thousands, if not millions of years. And this right here, this is an international research base consisting of Soviet at the time. This was prior to the fall of the Soviet Union. This was a Soviet research base. American and French, and then other international groups as well. And this actually shows that even during times of major political instability, Um, Scientists are so eager to be able to look into the past that they work together. They're not just trying to screw each other over, they actually collaborate together. And so this is one good piece of evidence or one good sign um, prior to the fall of the Soviet Union that relationships between us and the Soviets were getting better. Um, Actually being able to, as a team, utilize the research base. So that is ice core data. Another big source of paleoclimate data is tree rings. Every single year, a tree grows a new outer layer. It grows a new outer layer, and that outer layer represents that particular growing season. Well, what we can do without harming the tree, we can actually bore a very small hole into the tree and extract this tube that provides a sample of the of the ice core, of the tree rings that are present inside that tree. Um, we can also do this with dead trees or trees that have fallen over. We can cut them and get a whole disc. But for live trees, we can actually bore a hole in, pull out the wood, and then what we end up getting is we end up getting this little tube of different layers of different rings that represent different growing seasons. And this gentleman right here, this is Edward Cook, also known as Dr. Dendro, because the science of studying tree rings is what's called dendrochronology, of the Lamont Doherty Earth Observatory at Columbia University in New York. And this was him on a research trip in Tasmania. That's that little island just south of the main island of Australia. And he has just bored a hole into this large tree and pulled out a tree ring core. And so there he is holding on to that right there. And then finally, the third thing that we can use are what are called sediment samples. So this particular ship right here, this is the Joyous Resolution. It actually goes out to the open ocean. It almost looks like an oil rig, but it actually goes out to the ocean, drills a long tube using a boring tool into the sea floor below, and then pulls out these long tubes of sediment. And just like with ice cores and tree rings, each layer in that sediment represents a different time period, and we can investigate the chemical makeup of it, what kind of fossils are present, to help us reconstruct the past environment. This little video right here is a really, really good video. I'm a little nervous about actually showing this video here on my actual recording because I don't want YouTube to flag this and take it down, and then half the class doesn't see it. That ends up being a pain in the butt. So what I'm actually going to do is I'm going to link that video in comments. It's just a 1 minute briefly describing how the Joyous Resolution works. And even to this day, the Joyous Resolution is still out there collecting sediment samples from different parts of the Arctic and the Antarctic, and actually different parts of the Atlantic and Pacific Oceans as well, so that we can actually be able to get a reconstruction for environments in different parts of the world. So the Joyous Resolution is still doing this. Even now, even during COVID, they actually have protocols where people are isolated and quarantined for 2 weeks before they get on the ship. And then when they get on the ship, there's still social distancing and everybody has to get tests and so on. If you're watching this from, a time where the COVID pandemic has passed, hopefully that'll be a figment of the past in the not too distant future. But just a little thing showing that this is still happening right now. And this is what they pull out of the ground. These sediment cores from the ocean floor are pulled up, and then they are in long hollow tubes and then prepared for research. And then you have climate scientists who are actually on the ship performing research, looking at the individual layers, to determine what on earth happened during that time, literally. Now, that being said, this is the different proxies and how we collect them. But once we collect them, what do we do with them? Well, this actually takes us into the next two videos that we're going to talk about, but I at least wanted to briefly introduce you to what we do with them before we go into those next two videos. The first thing we want to do is we want to date it. So when we get some kind of sample, whether it's an ice core, a tree ring, or a sediment core, we want to date it. What I mean by that is take it out for a nice bottle of wine, get all dressed up, treat it to a nice steak. No, I'm just kidding. Obviously, that's not what we do. We want to figure out when this particular sample represents. What time does it represent? And then the second thing we do is we analyze it. We look at its chemical composition. We look at, are there any fossils present? There are different isotopes we look, widths of rings, layers, and so on. And each one of those things tells us quite a bit about what was going on in that particular time. Now, in these next two videos, I'll actually break these two things up and really geek out them about a little bit. So hopefully you'll join me for that. That's it for this video. So hopefully you'll join me for that in the next two videos.